Hello and welcome to today's educational webinar. I'm Ed Potasnik. I'm Executive Director with New Jersey League of Conservation Voters. I want to thank you all for coming and just invite you to please change your name in the upper right-hand corner of your picture or the screen that has your name on it. You can click the three dots and click rename and then put your name in there. That's really helpful. We're going to be taking questions from the chat box. So at any time, if you have a question, feel free to drop that in there and we'll get a chance to get to those. And it's helpful to have your name so we could say this question came from this person or a few people and name them. At the bottom of the screen, you can also do that. If you're from a legislative office, we just ask if you could please identify which legislative office you're from. I know we have a number of folks here from work for the legislature or members of the New Jersey legislature and all the way through our federal legislators, our members of Congress and the United States Senate. So we're really happy to have you here. Again, my name is Ed Potasnik. I'm Executive Director of the New Jersey League of Conservation Voters. We're the political voice for the environment here in the state of New Jersey. And I want to thank the legislators who are joining us, the staff, and all of you, our members and folks from the public. We probably have some folks from the news media also in attendance. We're really happy to have you with us and for attending. It's great that you have interest in new laws that are being considered here in the state of New Jersey. And to give you a brief overview of what we're going to talk about and the goal of the legislation, this is about A5223. Which its goal is to incentivize state procurement of low carbon concrete. So right now, currently, cement is responsible for roughly 7 to 8% of global emissions of greenhouse gases, greenhouse causing gas, global warming gases. The state is a major purchaser of concrete. And so as a big purchaser of concrete can play a role in advancing low carbon concrete and helping to mitigate or lower our impact on climate change. And as we've seen, the state of New Jersey is really dedicated to fighting climate change. We've seen recent actions and legislation taken over the past few years. So after I finish up speaking here, we're going to have Susan Dorward from the OpenAir Collective will speak, and then we're going to have Matthew Adams, who's a Ph.D. and assistant professor of civil engineering at the New Jersey Institute of Technology, will be speaking as well. And then finally, we're going to wrap up with Assemblyman Andrew Zwicker, the sponsor of the bill, and then we're going to get into our question and answer section. And so now that you've changed your names, you have a little bit of a sense of where we're going and what we're going to be doing today. I'm going to pass it over to Susan to take it from here. Thanks again for joining. Thanks.
Great. Thanks, Ed. Let me just share my screen. Hold on. I will present. All right. Welcome, everyone. I'm Sue Dorward. I have worked as the sustainability coordinator for Raritan Valley Community College for over a decade, and I studied global warming and carbon management at Columbia University. I'm a volunteer with the OpenAir Collective, which is a grassroots volunteer climate advocacy organization. We have no ties to industry and are not promoting any particular company or product. We are not being paid for this. We're not lobbyists. My co-presenter, Dr. Adams, is OpenAir's technical advisor. So OpenAir has a team of 6 New Jersey volunteers and growing, advocating for A5223, which is based on a New York State bill, which is called the Low Embodied Carbon Concrete Leadership Act, or LECCLA. So I'll often refer to A5223 as New Jersey LECCLA. Embodied carbon for our purposes refers to greenhouse gas emissions from manufacturing concrete, including sourcing of all the materials. So LECCLA is gaining national attention and momentum in other states. New Jersey and New York are being recognized as leaders for having the first LECCLA bills. And low carbon concrete is increasingly in the news. You may have heard that Bill Gates mention it in recent interviews about his new climate book.
So Susan, I'm just going to mention, we're getting a little bit of noise. And I don't know if it's like, is your microphone on your wire? Is it rubbing?
Oh, maybe it's my papers were on my on my microphone, maybe? Is
That's
that better?
That's a million times better. Yeah.
Oh, okay. Thank you for letting me know. Sorry about that.
Absolutely.
It is not letting me share. Here we go. All right. So we already have 5 sponsors and co-sponsors. Assemblyman Zwicker introduced the bill, and Assemblywoman Timberlake joined as a primary sponsor. Assemblywomen Huddle, McKnight, and Chaparro are co-sponsors. And OpenAir is looking for members of the public to reach out to their legislators to co-sponsor and support the bill in the Assembly and to sponsor the bill in the Senate. New Jersey LECCLA's approach should appeal to both Republicans and Democrats, and it would be great to add some Republican co-sponsors. A variety of national and local organizations already support the bill. This includes architecture, infrastructure, engineering, business, and environmental organizations. NRDC has been a great partner, and you'll see a Somerset County Business Partnership there. It was at their Sustainable Somerset meeting last year that I first mentioned the bill to Assemblyman Zwicker. The New Jersey Conservation Foundation, the Association of New Jersey Environmental Commissions, or ANJEC, and the League of Conservation Voters and others shown here all support the bill. And the U.S. Green Building Council, which runs the LEED certification program, wrote us a letter supporting low embodied carbon policy in New Jersey. All right, so just quickly the agenda, I'm going to go into some of the basics about concrete, some of which Ed already told you about. I'll talk about the bill in detail, and then Dr. Adams will talk about low carbon concrete and how that's achieved, and get into the more of the hands-on technical aspects of it. And then Assemblyman Zwicker will speak a little bit, and then we'll do Q&A. All right, so why do we care about emissions from concrete? We make 30 billion tons a year of concrete globally. It is the second most used material in the world after water. And as Ed mentioned, cement accounts for 7 to 8% of global greenhouse gas emissions. If cement were a country, it would be the 3rd largest emitter. So reducing emissions from concrete can have a big impact simply because we use so much of it. So I mentioned both concrete and cement. So I want to make sure you understand the difference. Cement is the glue in the concrete. Cement is mixed with water and aggregate, which is made up of sand and gravel. It turns out that most of concrete's emissions are due to the Portland cement for the glue. Now this chart shows on the bottom line just greenhouse gas emissions from different steps in the cement manufacturing process. And you'll notice that there's a higher number there for the calcination process than there is for the fossil fuels. And that's an important point because most emissions happen from cement in the chemistry of heating the limestone. The heated limestone releases CO2, which becomes clinker. This releases more emissions than are released from the fossil fuels that are burned to make the heat. So reducing or eliminating the fossil fuels does not solve the cement emissions problem. And the Internal Energy Agency and others have identified carbon capture and reducing the amount of clinker in cement as the most impactful ways to reduce emissions. So the 2 main approaches that we're looking at to achieve low carbon concrete are to use less Portland cement and to capture CO2 and turn it into a solid in the concrete. It is even possible to put so much CO2 in that the concrete becomes carbon negative. So a great local example of low carbon concrete comes from Port Authority. They've been requiring that all of their concrete have at least 30% substitute materials replacing the cement. So in general, and I asked them about this, contractors can provide this for no additional cost. A new substitute option that they are excited about is ground glass pozzolan, which is made from glass that would otherwise go into a landfill. Port Authority is also working with academics on a low carbon concrete strategy, and they're going to be requiring environmental product declarations for concrete. So let me show you what that is. So here's an example. An environmental product declaration, or EPD, is like a nutrition label that shows the environmental impacts of a product, including the global warming potential, shown here in the red box, which quantifies greenhouse gas emissions for a cubic meter of concrete. So LECCLA, our bill, requires the use of EPDs. So we're going to see this again later. All right, so let's talk about the bill. As Ed mentioned, LECCLA focuses on state procurement. The state is a major purchaser of concrete, making it a prime candidate for being an early adopter and driving demand for low carbon concrete. There are several policy precedents for New Jersey LECCLA. There's California's Buy Clean program, which sets climate-based purchasing requirements for construction materials, though it does not address concrete yet. The United States Conference of Mayors in 2019 passed a resolution urging all cities to consider using CO2 mineralized concrete. So that's when the CO2 gets turned into a solid in the concrete. The city of Portland, Oregon has a low carbon concrete procurement program. And I've already mentioned the New York LECCLA bill, which is still pending. And it turns out that the Netherlands has a very similar policy to LECCLA that's been in place for 8 years already and has been used for the procurement of over $1 billion worth of low carbon concrete. Okay, and there are 3 components to New Jersey LECCLA. One is a bidding advantage for low global warming potential or low emissions. The second is a bidding advantage for doing carbon capture, utilization, and storage. And the third is a small tax incentive for concrete plants to create environmental product declaration. The bill only applies to state procurement of concrete. It doesn't apply to the smaller jobs. So 50 cubic yards is about, like what you would have for the foundation for a single family home. So only jobs bigger than that. And the obligation is transferred to general contractors. So if the general contractor is subbing out to subcontractor for concrete, the obligation still applies. And the innovative feature of LECCLA is that it combines market-based competition with environmental impact, what we refer to as climate competition.
Just so you're kind of getting some of that mic interference again.
Sorry.
That's okay.
Instead of competition based solely on price, climate competition is based on a combination of climate impact and price. And we measure climate impact by using the global warming potential number, the one we saw in the red box earlier, from environmental product declarations. So if concrete companies submit certified EPDs for their concrete mixes, we can make apples to apples comparisons of their global warming potential numbers. Certified EPDs are based on a National Science Foundation standard, and there are programs that can generate them automatically. So here's where the climate competition comes in. Bids with low GWP scores can receive a discount in the bidding process. Details of the bidding discount process are determined by the DEP commissioner and the state treasurer. Those details are not in the bill, so it allows for flexibility. But let's walk through a hypothetical example. So LECCLA provides a maximum discount of 5% for global warming potential. So say we have a project that gets 4 bids with GWPs. The bid with the lowest GWP, the lowest emissions, could get the maximum 5% discount. So if they bid the job for $100, the bid would be treated like it was for $95. Bids with higher GWPs or more emissions would get a smaller discount. This could be on a sliding scale. And there's no requirement to submit an EPD. If a contractor doesn't submit one with their bid, that bid just doesn't get a discount and it's competing on price by itself. And there could also be a GWP threshold to ensure that bids with high emissions don't get a discount. So in this example, a threshold of 400 would mean that bid 4 wouldn't get a discount, but it would still be considered. Okay, so in addition to incentivizing low global warming potential, we also want to incentivize carbon capture, utilization, and storage. So LECCLA has a second discount for CCUS. Like before, the details of how to do this are determined by the DEP commissioner and the state treasurer. So let's go back to our previous example. LECCLA sets a maximum 3% discount for CCUS. So in this case, if bid 1 uses CCUS, its total discount could be increased by 3 to 8%. That is the maximum total discount. So what is the price impact of these discounts? Does this mean that costs will go up by 8%? The beauty of this approach is that bids are still in price competition with each other, and the discount does not change that. The bidders don't know each other's bids or GWP scores, so they're still incentivized to submit a low bid. Climate competition rewards bids that give the most climate benefit for the lowest cost. And then the final component of the bill is a tax credit to help concrete producers pay for the creation of EPDs for their concrete mixes. The credit is for a maximum of $3,000 per concrete plant. Now, there are only 55 New Jersey plants approved by the Department of Transportation. So if they all got the credit, that would be a cost of $165,000. Concrete producers would only be eligible for the tax credit for 2 years. So just in summary, LECCLA's approach has a number of advantages. It is technology agnostic. It's not picking a specific method for reducing the emissions. It's performance-based. It allows for concrete producers to combine multiple solutions in the same concrete mix. So it's to stack solutions. So for example, they could substitute for the Portland cement and also do CCUS. It rewards innovation by having a flexible discount mechanism that can adjust as new technologies come to market. It has no mandate and does not even require that concrete producers provide EPDs. And it maintains the cost benefits of competitive bidding. So with that, I'm wrapping up. Please, if you have any questions or are interested in contacting your legislators to support the bill, please send me an email for more information and resources. I'll put my email address and the OpenAir website URL in the chat. And now I would like to hand over to Dr. Matt Adams. Thank you.
Let me just share. So thank you, Sue, for that, and thank you for having us here and coming to this webinar. So I want to talk a bit about the technical side of this. And so my name is Dr. Adams. I'm an assistant professor at NJIT. I got my PhD in civil engineering at Oregon State University in 2015, and I've been at NJIT ever since. And I'm co-director of the Materials and Structures Laboratory at NJIT, where we do a lot of experimental research on making concrete more sustainable and more durable, and working with a lot of these novel materials. So just to kind of talk about concrete a little bit and orient us all to what concrete is. Concrete is a lot like a cookie. In a chocolate chip cookie, you've got eggs, flour, and butter. This is kind of your glue or binder system. You've got sugar and chocolate chips, that's filler and flavor. And then you have these modifiers to make sure that everything is light and fluffy and you get the right balance of everything. Concrete is very similar. We have cement and water, that is our glue and our binder. We have sand and gravel, which is our filler. It's really important for us to have that in there. If we made the whole system out of cement, it would be very expensive and very unsustainable. And then we have a whole bunch of other chemicals that we can add in to try to improve that. But like a chocolate chip cookie, you have your basic version that is just cement, sand, gravel, and water. But we have all of these variations that are available to help us change up the mix and give us the properties that we want, including helping us improve the sustainability and reduce the carbon footprint. So what is concrete? Like I said, it's about 1 to 8% air, 7 to 15% hydraulic cement, which is your Portland cement in most cases. And this is going to be where the majority of your carbon is coming from. You've got water, and then, like I said, most of the material in concrete is aggregates, so sand and gravel. So there's lots of alternatives here that will help get us to this green concrete mixture. But why do we need to do that, right? So concrete, as Sue said, cement is responsible for about 7% of the total CO2 output. If you look at concrete overall, we're adding another % or 2 on top of that. And where does this all come from? Well, the biggest issue is that concrete is produced at such a massive scale. We produce almost 2 cubic yards per person per year in the entire world. And so that is, you can start to imagine how much concrete we're making every year. On a per unit volume basis, concrete is one of the more low carbon emitting materials out there. So if you compare concrete to steel on a per unit volume basis, it's much lower. But of course, we make so much more concrete than we do steel that its impact worldwide is much more prevalent. So that is a problem that we need to address to make sure that we can control that carbon. And where does it all come from? Well, most of it's coming from the cement. You get some CO2 production from quarrying out the raw materials, grinding it down, preparing it, turning it into a powder. That's really only about 10%. Around 40% comes from what we call the thermal emissions. So this is what is being output from the heating up of the material. We have to heat it up to about 1400 degrees Celsius to get the chemical changes that we need. But over 50% comes from what we call process emissions. And so this is what Sue talked about a moment ago, where we actually have to break down limestone. So when we make cement, it goes into a rotating kiln. This is usually around 300 or 400 feet long. It's quite a large facility. We don't have any cement production here in New Jersey, but there's some in New York and Pennsylvania. And we put our raw materials in at the top. We have a heat flame coming down at the bottom, and those materials, as they move through the kiln, heat up and change. And so we use all sorts of fuel sources to try to heat that up. We have some that are more CO2 intensive than others. There's been a lot of work to try to shift the balance of that to make it as environmentally friendly as possible. There's been a lot of work in the efficiency of the kiln, making sure that the heat is contained, that we use any heat that's bled off to do other things. But that only gets us so far. because we have this process called calcination. The limestone that we have to use as a raw material, we need to break down to get calcium oxide. And that is one of the most important components in cement. And so when we break down that calcium carbonate or the limestone, the CaCO3, we heat it up and we release CO2. And that CO2 mostly gets lost to the atmosphere at the moment. There's a lot of new technology that's being developed to try to capture that as well. That hopefully will be coming on in the coming years. But for right now, that's a lot of CO2 that gets produced from this system. Other sources outside of that, of course, is the mining, but really these are mining and transportation, but these are minor compared to what is coming out of the kiln just from the chemical process. So how can we reduce that embodied carbon and make our nice green concrete? We actually have quite a lot of options here. The first one that we typically talk about is reducing the Portland cement. It's really difficult for us to replace it entirely. We have some alternative cements that work well, but for the most part, other types of cement need to be produced from materials that are not abundant in the earth, right? Portland cement comes from, we use limestone and clay. That's really all you need to make Portland cement. You can get that everywhere. Other materials, like we can make great cements out of phosphates, but we need all the phosphates that we make to use as fertilizer. And there's no way that the phosphate supply, even if we weren't using it as fertilizer, could supplement what we need for cement. So our first task is to try to reduce this amount. So Portland cement is what we mostly use. This is around 90% of the market. We also have some of these alternative cements, like calcium aluminate cement or calcium sulfoaluminate cement. They're similar in composition to Portland cement. And then we have these kind of newer systems, magnesium phosphates, which again are very expensive and we can't produce a lot of, and geopolymers, which are difficult to work with, but coming on more, and those use non-Portland cement materials. So what's kind of the difficulty with these? Well, those first two that are similar to Portland cement are already widely used, but we're talking about 5 to 10 times the cost of Portland cement. And they're really meant for very specific uses because they tend to set and harden very quickly. So they're a little bit more difficult to work with. Whereas, our Portland cement, we get a couple of hours. That gives us the time for the workers to bring it out to the field and place it. These ones we're talking about hardening in 10, 15 minutes. And so it gets really difficult to work with. And then these other materials are there's really limited availability and they don't behave the same way as our typical hydraulic cements. So what else can we do? We can use what are called supplementary cementitious materials. So these are things like we grind up limestone and we mix that in with the cement. We use waste byproducts from other industries like fly ash and silica fume. And then we have newer products that are coming on like ground glass pozzolan, which is crushed up waste glass, and calcined clay, which is clay that has been heated up. Locally, we have a new plant for ground glass pozzolan that came online in Connecticut that is really going to help us access that great new SCM. And so we replace a portion of the cement with these. We can't replace all of the cement with these because we need some of the chemical products that come from the mixture of water and cement to make these work. So if we were just to replace the cement with, say, fly ash, it would never harden. We wouldn't get a solid product. We wouldn't get any of the properties that we need. These really have a moderate cost depending on the SCM. They're mostly about the same price as cement, so you're not really seeing a huge cost increase on them. And the benefit is that a lot of them are actually already heavily used in the industry. It's just not standard. We haven't made it sort of the baseline yet. So, ground limestone is another one that I just want to focus on for a second. Here where we're placing usually around 12%, no impact on strength or durability. This is something where you can try to help make a impact. Right now we have a low availability of this in the US because it's just not requested as much, but we can get it delivered from Canada. Even with that transportation cost, it's typically a better product or a better carbon performance. But this is something that's really starting to come online a lot here in the US. Another thing we can do is reduce our cement through mixture design. So a typical mixture will have 500 or 600 pounds of cement per cubic yard. But we can actually reduce that by ensuring that our aggregates are well chosen for their size to make sure that we have less space in between them. So we actually need less cement, and we don't see any strength loss in this. Right now, this is difficult because it increases the cost of the aggregates because it requires our aggregate producers to make a different material. But again, as with all of these products, as it becomes requested more, those costs will go down. The next one that we can talk about is incorporating CO2 directly into the mixture. So this is something like what CarbonCure is doing, or Solidia. Solidia is here in New Jersey. They're a technology company here in New Jersey. With CarbonCure, you're looking at about 1% by mass of the cement that you're mixing in CO2. So it's not actually a lot of CO2, but the key there is that mixing it in increases the strength and performance of the system so you can reduce the cement content. Solidia Technologies product is a little bit different. They have a material that they actually cure. They force CO2 into the system while it's curing. So you actually get quite a bit more CO2 in that system. So these are new technologies that are starting to become more and more available. CarbonCure specifically is starting to work with plants here in New Jersey. Solidia Technologies is already selling some of their products around. And so, these are things that are definitely here already. We can also change our aggregates using recycled waste aggregates. We can easily replace up to 20 to 50% of our aggregates. The main benefit for CO2 in this is that we reduce transportation costs with landfilling our waste and bringing in aggregates from new places. It's not a huge CO2 improvement, but this is generally a good sustainability practice because we're talking about reducing landfilling and reusing waste. We also have some other alternative aggregates like crushed up glass, and then these new types of aggregates that are coming on the market. In some places, we don't have them here yet, where they're actually taking CO2 and mineralizing it into calcium carbonate, basically making limestone and depositing limestone around that aggregate. And then you can use it as the rocks in concrete. Of course, you can do all of that, but your best option, the thing that we always want to do first, is make sure that when you're working with contractors that you design for durability. You can imagine if you design a sidewalk that lasts for 100 years, you get half the CO2 output than a sidewalk that lasts for 50 years, right? So always trying to make sure that we're planning our infrastructure for the long term, and designing it to last for the long term is a key element. And then not over designing. When we talk about public projects, right, we're generally not talking about the Burj Khalifa, where you need, where you have a mile tall building, we're not talking about something that big. We don't need that product. So let's not use it on our sidewalks, right? Let's not use it on our bridge decks. Let's make sure that we're designing with purpose so that we don't use more cement than we need. And we're making all of these choices carefully. So in summary, there's many ways for us to reduce the embodied carbon in concrete. And the key that I want to stress here for this group is that some of them are actually already being used extensively. And so what this bill is actually asking people to do is not taking in necessarily new technologies. It allows new technologies to come in, it helps promote new technologies, but we already have the technologies that have been used quite a bit. This is just trying to help make sure that those are actually being employed. These changes, if you have a plant that isn't employing these, the changes can be done quickly and easily, but it really requires communication between the engineers and the contractors and the towns and state that are procuring these. Really having the state request these is the key element here, because that is going to make sure that the products are actually being supplied. So with that, I just thank you, and I'm happy to answer any technical questions that come up about this.
Thank you so much, Dr. Adams. Really appreciate that. We're next going to go to another doctor and also an assemblyman, Assemblyman Andrew Zwicker. I think you're with us. And by way of background, just so folks know, Assemblyman Zwicker in his day job works as head of communications and public outreach at the Plasma Physics Laboratory in Princeton Plasma Physics, as we call it. He's also the chair of the Science, Innovation, and Technology Committee, sits on the Higher Education Committee, and Regulated Professions as well. Welcome, thanks for joining us. Happy Friday.
Appreciate it, thanks everybody. Really, just a thank you to Sue and to Matt too. Thrilled to hear the technical discussion as well as the legislative piece here. As Ed mentioned, I've spent my whole non-political career working on non-carbon energy. I must be the eternal optimist because I work on fusion energy, energy source of the future. We shall see, and cannot wait until fusion is part of the discussion on a renewable energy portfolio.
Right around the corner, right?
What is it, Ed? Energy source of the future?
Yeah,
always
right around
has
the corner.
been,
Yeah,
always will be. There's a whole other discussion not related to concrete about how, but it's somewhat relevant, how the public sector, the private sector, universities can work together on technology, right? And what does that look like? Because in some ways, that's what we're talking about today. We're talking about technology being able to create identify a problem, right? Identify a solution, and then propose public policy to incentivize that solution. And I have to give a special shout out to Sue, who is the person who's driven this from the beginning, who approached me about, hey, how much you know about low carbon concrete? And quite honestly, the answer was not much. And as she took us through the bill and Matt talked about some of the technical pieces, astounded, and not surprised, but astounded to learn what percentage of CO2 emissions is due to concrete production. So I'm thrilled to support this, thrilled to be the prime sponsor of this bill for a couple of reasons. One, and some of this came out, right? One is because, 7-8% of the world's carbon dioxide. So this is a low-hanging fruit. We talk about carbon pricing, we talk about build out of wind, and we talk about increasing of solar and microgrids and storage, and, all the things around energy production. There's a lot less conversation, at least in Trenton, in my opinion, on some of the lower hanging fruits, which how do you even stop carbon from being emitted in the first place? And, what does it mean in terms of energy efficiency, and what does it mean in terms of building materials, right? And so really I'm thrilled to be a part of this. I think the other piece about this, and I give all the credit to Sue, is that this proposal, you talk about carrots and sticks. This is all carrot, no stick, right? As she laid out, this is about the fact that we get that there's a price differential and that but at the same time there's a market demand. So let's incentivize that price differential. Let the state take on a bit of that so that people can propose, right, that know that they're going to be cost competitive and rewarded for the fact that they're going to drop their total carbon production in a something they're going to build. I also think there's precedent for this, right? California has shown that this is possible. There's a program in Oregon to show this is possible, a program in Hawaii to show this is possible. And this bill is based on a bill in New York, but it is unique in proposing the climate competition mechanism that you heard about earlier. I think this is, how you do good public policy. You take stuff that has come out of the research community, stuff that has come out of developing these other materials that Matt talked about. You put it together with a incentive program and an acknowledgement that more concrete is going to be poured in New Jersey. And then you figure out how to make it in such a way that moving forward, we can have low carbon concrete become the norm. Because we also know the more it's used, then that's economics, and that'll drive the price down, right? The incentives stay in place if the price drops down. The end goal is to get us to that point. And maybe someday there's other materials that can replace the durability and strength of concrete in a cost-effective manner. But for now, let's do the technological changes. So, and then the last thing I would say is I'm really excited to see this bill move forward. I'm going to need all of your help and your networks and your organizations to do this, right? Because people need to understand, you already understand the technology, the cost, the need, and the potential. But there's definitely outreach that needs to happen throughout the state, whether it's within the legislature or whether it is grassroots organizations, environmental groups, whatever it might be. So I really look forward to working with each of you. And like I said, very proud to be the prime sponsor of this bill. Very grateful to your leadership and your advocacy. Also happy to answer any questions, but like I said, really looking forward to the next steps.
And we do have a couple questions, but while you're on the screen here, tell us a little like the Senate. Is there a Senate companion? Or what does the legislative outlook look like? My understanding is there isn't. So I don't want to test you.
Okay.
Yeah.
Well, so Ed, no, I'm smiling because when you said Senate, I thought you were going somewhere else. So
the Assembly bill is you're the sponsor.
I don't think there is yet. And I haven't had conversation. I've been a little preoccupied. That's where I thought you were alluding to. So I don't believe there is yet, but there are some really strong environmental advocates on the Senate side. So let's work together to make sure there's a Senate sponsor and we move it together in both houses.
Okay. And what does it looks like the prospects in the Assembly, would you say, on a scale of 1 to 10, 10 being like easy breezy, 1 being like budget?
So 1 being budget, 7.
Okay.
7?
So
look, there's, so going right into the weeds, right? In some level, or the practical pieces of it. There is budgetary issues. I mean, state has to be willing to accept this piece of the fiscal part of it. And there's some budget parts, but it fits so well into Governor Murphy's overall carbon reduction plans. I think it's also, the budget process this year, as it always does every year, is going to really take up a lot of the oxygen, a lot of the carbon dioxide in the room, if you will. So I am confident, right? I've had conversations already, not just with environmental folks, but with other stakeholders about this, to make sure people understand that this is actually a job enabler, right? That this doesn't take jobs away. This actually adds to jobs. This is not making statements about what projects to build. This is about how to build those projects. And once those conversations are had, I'm hearing really strong support. So that's why I would say 7, with the caveat of there's a lot of things swirling around right now.
Well, that's good to hear. And certainly some of the takeaways here are, no bill happens on its own without a dedicated group of individuals working with legislators and educating the community writ large about the impacts. And there's always stuff that comes out. For everything, there's a good idea. There's somebody who thinks it's a bad idea. And sometimes they have things that are true and we want to fix and hone the legislation. And sometimes they're just saying things because they don't like change, or it's going to somehow impact the business as usual, and the business as usual model is polluting, causing us to have more frequent and intense storms, is causing people to have other harms. And they come at a physical impact and also a monetary cost. Flooding from a big storm, Texas, we don't have to go on about Sandy. These things have costs, but I want to go into costs because a lot of people in the chat have been posting things about, tell me a little bit more about the cost. And I didn't see dollar signs in the presentation exactly, but can someone talk a little bit more about the financial incentives and what it means to like the state and the impact on the budget? Are we talking about 10 cents? Are we talking about $10 million, $10 billion, or in the federal level, $10 trillion? What are we looking at here?
Well, I can speak to that a bit, and then probably Matt has more information than I do. I mean, like I said, Port Authority is already doing it. And they say it's no additional cost to get these SCMs in there right now. And then we did work, there was an OpenAir person in New York State who worked with a town to get a low carbon concrete project done. And the contractor was able to do that again for no additional cost to do the SCM. So like Matt said, a lot of it can be done already. The concrete companies already have the materials or can get the materials. And so there's no cost. Once you get to maybe the newer materials, like the pozzolan, the glass pozzolan, that's a little more expensive from what I understand. The carbon cure is a little more expensive, but people are adopting it. I mean, they've got hundreds of plants across the country. I don't know, is it 600 plants or something that are already using carbon cure? And so they're finding it economical. So this is really more of, we can do it, let's make sure we do. And there's maybe a little bit of cost for the newer technologies, and those are like 3% that we're talking about. So, that's why the numbers in our bill are, 5% discount, 3% discount. We're expecting that that's going to cover the additional costs pretty well. So Matt, do you want to say more?
Yeah, so, in general, the things that we've been using all along are comparable in price. The construction industry is very price focused. So things that come out that are much more expensive are typically not well adopted because of that. So, you'll often see these new products coming out and they're, purposefully being priced in that same range. Otherwise, they'll never sell. Some of the newer technologies, like Sue was mentioning, comes with some startup costs. And so that is, with the carbon cure, there's some equipment that needs to be leased from the carbon cure company. And then also just testing the product to make sure that it works with their local materials and to get the mixture right. Concrete is a local material. The mixture that I use in Newark is different from a mixture that's used in Atlantic City, because the aggregates that you use are going to be different. The weather that you're seeing might be a little bit different, right? So they need to do some upfront testing to make sure that the exact proportions they're putting in are the right proportions. And so one of the benefits with this bill is that it helps to incentivize that upfront cost, and then long term, as people understand these more and get that equipment set up, the costs go down over time. So there's this sort of startup incentive is really helpful and important.
I mean, it sounds to me like there some options here are at no cost from the experience, and then there are these more advanced technologies like first adopter type things that might have an initial higher cost, but over time we would see those go down. Is that about similar if I had to just say it in an elevator speech? I just want to make sure I heard it right. Okay, great. And then I always like to solve problems, two things at once, right? And so New Jersey is the most densely populated state. We have the highest amount of impervious surface, concrete and pavement, buildings. So pervious concrete is something that I'm very interested in. because if we can help when we put in driveways and highways and parking lots be porous, and that the land do what nature does, which is to filter our water and keep polluted runoff out of our waterways and our drinking water supply, that's a win-win. You didn't talk a little bit about that, Dr. Adams, but is that possible with these different ratios and the technologies that we're looking to employ to still do a porous version of that?
Sure. So porous concrete, really what makes it porous is that we take the sand out, or we reduce the amount of sand, and that basically creates these open pathways through the concrete. But we still have a lot of cement in there holding the coarse aggregates together. And so these same technologies can really be used to help replace some of that cement and reduce your overall carbon footprint. Porous concrete, you have to be a little bit careful. It's obviously something we can't use in all cases because it's not as strong, but it is so useful from a sustainability standpoint in trying to reduce our hard surface around us.
Yeah, I almost wish there was a way in the legislation to incentivize that piece too, that the concrete would be porous as well as being good for climate, getting rid of greenhouse gases and helping tackle the climate crisis. I'm just making an amendment suggestion here in the webinar. And then in addition, some folks have asked, and I want to acknowledge as well, we have a very knowledgeable individual, Sean Mohan, who has been answering a lot of the questions in the chat, but for people on video only on Facebook streaming, they might not see the chat. We appreciate that. Someone had asked a question about, well, what is the magic number here about 50 cubic yards and having that be when this would kick in? Is there some rationalization to that?
Yeah, it was really just meant to not have a lot of overhead or introduce, a big process to something that's a little job that people just want to get done. And the smaller jobs, there probably aren't that many of them at the state level anyway. So it's just a matter of practicality. For a smaller job, you might be using a smaller concrete plant that isn't going to be worried about EPDs because they don't have a lot of big jobs with the state.
I agree with Sue. That's exactly right. It wasn't that was a magic number, but it was trying to strike a balance between these little projects and these big ones that are, needing significant amounts of concrete. So, yep.
Awesome. And there was a question here that was posed too about having conversation with the New Jersey Department of Transportation as one step change for the state concrete that could happen with the adoption of the C595 Portland limestone cement. According to the question, at least 30 states have accepted, and now New Jersey has not yet done that. And that would result in about 10% reductions and immediate impact to concrete. So any conversations happening in that area? I'm not exactly sure about this. It sounds pretty technical to me. Maybe someone could explain that a little bit too to the rest of us.
Not from my side. It also
I
sounds
can't.
like it might be solved through regulation, perhaps, but I don't know the technical. If you want to talk about fusion, I'm your guy, but that's the technical person on concrete.
Yeah, so Portland limestone cement is just it's Portland cement that's pre-mixed with the ground limestone material.
Okay.
It's a great product, and it's something that we should be using a lot more of. I do work with the DOT on some research projects, but I'm not sure why they haven't approved it or where they are on the stance. But hopefully things like this, where we have bills that are encouraging public procurement of low carbon systems will help push them towards doing more work to make sure that these products are approved in their systems.
Great. And that Lori T in the chat added a little bit more about this as well, kind of saying like, if New Jersey gets off its chair and gets involved here, we could see immediate reductions just in that alone, which is what I'm hearing as well. So question, like sort of theoretically, let's say we're very successful, all of us band together, do the important and difficult work of moving legislation. The state changes the way it's doing its concrete work. How do you see this as shifting the industry? Do other people follow suit? Do you expect towns, counties? Do we expect businesses like Wakefern Foods, ShopRite, largest employer in New Jersey of businesses, saying, you know, we're going to do this too. This makes a lot of sense. Kind of give us the future, look in the crystal ball.
I'll jump in by saying, I think a couple of pieces. One is, you know, the state has, if you will, enormous buying power, for lack of a better term, that will change the narrative, in my opinion, towards county, municipal, local projects and how they get it, right? I think also be, once this is successful, well, okay, if the state's going to incentivize state projects, then why shouldn't we start figuring out how to incentivize more local projects? So I fully expect there to be a ripple effect, if you will. And then importantly, you know, to have New Jersey show that, you know, like a few other states, that they're willing to take a leadership position and make sure that's known nationally. So I do see a bunch of different places for this to ripple through beyond just the projects that would come under this bill.
And maybe even inspire the federal government.
I cannot speak to the federal government. I never would. No comment.
I can speak from OpenAir's perspective. I mean, so OpenAir is, we've got teams in other states across the US looking at LECCLA, hoping to get it adopted in other states. But also we have, and federally too, but also we have a project called the Open Sidewalks Project, where we're hoping to work with Sustainable Jersey to establish standards for low carbon concrete sidewalks for towns. And also just working with the towns directly to educate them about low carbon concrete and see if they can start adopting it in their projects. And for sidewalks as kind of the low-hanging fruit of it's an easy project. You don't have to worry so much about safety. You can try it in a small area and see how it goes. And that gets the local concrete producers with who are doing the smaller jobs on board. So I just see that as more concrete plants are doing it, even for the state or for the town, it'll become more of a default, and they won't see it as, you know, they won't have hurdles to actually doing it. It's already there as an option.
Awesome. This has been a really great conversation. There are some other questions that have been coming in. Couldn't get to all of them, but we got through a lot. It was a lot of technical information, but also really inspirational about how everyday changes in what we do can have an impact. Just like when we choose to bring our own bags to the grocery store instead of using the disposable plastic bags that, excuse me, that kind of run into the trees and everything else. If you have more questions or want to get more involved, I know people put their contact information in there. Somebody in Zwicker, one of you folks from your office put your contact information in there. Feel free to reach out to us. We'll put you in contact with our speakers. And I want to thank you for taking time today to learn about this important issue. And we look forward to continuing to work with everyone and having your help in moving this issue forward, and particularly this piece of legislation. So thanks so much, Samantha Zwicker, Sue, and Dr. Adams. We just appreciate all your time and efforts on this issue.
Thank you, Ed.
Thank you, Ed. Thank you, everybody.
We'll see you soon.
Bye.
Thank you.